unit conversions are is this idea that there's 12 inches in 1 foot. And what that means, we're going to write them as fractions. So we can write it, there's 12 inches in a foot, or we can write it, and you don't have to write this down, you can just listen. There's 1 foot has 12 inches. So we write it one way or the other. When we do the math, which we'll do in a moment with the gnome, we'll know which way to write it. These fractions, the thing that is interesting is this is actually equal to 1. And you're probably looking at it going, that's not equal to 1. That's equal to 12. 12 divided by 1 is 12. And the key is there's units. Chemists work with units. Because there's units, this is not 12, this is 12 inches, and 12 inches is 1 foot. So these factors, they're called factors. That's why you'll usually hear me call it factor label, is these are called factors. So when we worked with metric, which was a chart at the top of the page, just a reminder how that chart works, because your test you're going to be doing right at home. The test will be during this time on Tuesdays, and they have a time limit. So they're on your syllabus what days they are. It's just the quizzes that you get the whole day to do them. So that chart, you have a chart just like it on the lab. How the chart works, let's say we're doing kilo. So it will say K is 10 to the third. And then you have M. So K is kilo. And little m is milli. And milli is 10 to the negative 3. So what that means, if we look at milli, and I'm pretty sure I talked about this the other day, is that 1 millimeter or 1 milligram or 1 milliliter is equal to 10 to negative 3 meters. Or when we put it into factor label, if we do a factor, we would say 1 millimeter, 10 to negative 3 meters. Or we can flip it. But how it always works, tell me if you can't see the red. One of the prefix, so 1 kilogram, 1 picogram, 1 zettabyte is always equal to 10 to the power of the base unit. And again, the base unit can be grams, it can be seconds, it can be liters, it can be meters, it can be bytes like on your computer, it can be pascals. We're going to see that as I go through the factor label here. So, questions. All right, so we're going to walk through this, my eraser. Oh, a couple more things before I get started. There are some, the metric, again, that's how these metric conversions will work. There are some US conversions. Yeah, I don't know where my good blue pen is. And so what you're going to want to do for midterms is have 1 page of your notes organized so you can follow it. Same with going through study sets and things like that. So those metric charts, you can pick which one you like. You can make one of your own. But if we go between US units, right, this is doing metric. The ones you should be familiar with, and again, you do not need to write this down if you know these. There are several students who are from other countries and they don't know these. So these are going to be the ones that we run into. So you might want to write these down. So 12 inches to 1 foot, 3 feet equal 1 yard. When you abbreviate units, you have to use the correct abbreviation. You don't get to make up one. This is one that many people forget, so you might want to all write it down. There's 5,280 feet in 1 mile. And again, if you can't see me or there's a weird glare, just let me know. So those are all distance. There are 16 ounces to 1 pound. So that's LB. I write it in cursive because otherwise you think I said 1B. And there's 2 pints to a quart. There are 4 quarts in a gallon. So this is actually a great time to remind you, today's October 1st. I hope if you haven't, that you go to my YouTube channel. There is a video about Healthy Change October, and it's a 30-minute video, and then you can decide, yeah, I'm going to make a healthy change. There's a couple of people have emailed me, and then at the end of the month, there'll be a place where you can upload what you did and how it went and stuff, or you can talk to me later about that. You're going to see me using these conversions. 32 fluid ounces, that's a Z, equals 1 quart. Now, if you go on Google, they'll have conversions between everything possible. Because of the environment that we're in, you guys are going to be limited to certain conversions. And so that way I can see that you have the methodology down. Once we get into the periodic table, we move completely only using pretty much the metric system. And what we're doing is we're going to learn this format. Some of you may have learned it in a high school class or in a math class, but it's so when we do the math with the periodic table, we have this system down. All right, so we're going to talk about the gnome, and I'm going to be a gnome. In case you don't know what a gnome is, so there's my gnome hat. My headphones. And so I asked myself, I got tired of writing boring questions, so I write stories. You can ignore my stories. What you need is the number. So a gnome, the G does not stand for gnome, it stands for gram. Gram is just a G. GR actually means something different. So turns out that's how much a gnome weighs, and I want to know how many ounces it is. So we're going to do this with conversions. Now, some of you have learned how to do it. If you worked on the metric, like Christian was here earlier, and you can do it where you say, okay, I'm going to multiply by these fractions like that. You can do it with parentheses. Again, don't write this part down. You kind of have to find your own way. How you're going to see me do it on the board is actually a really great teaching method, and you can use it that way also. But you're going to have to do your problem solving in this format. When you're initially learning it, a lot of students struggle with it, but once you get it, which will be by the end of next week, it just starts rocking, and it makes everything as we go through the term much smoother. So I do what I call our boxes, and only 1 unit per box. And that will become important like when we get to number 3. And what you do is you take, it's called unit conversions, because you take this unit, the grams, and you bring it down here. Not the number, just the unit. And I'm trying to change from metric to the US units. They're not actually called US units, they're called imperial units, because that's what the empire used, right? So I'm going to change grams to pounds. And at the top of that page in the notes, it'll be on the top of, for those of you in 151, top of the page in the lab, top of the page in the next study set, I think study set 2. There are certain US to metric conversions that we're going to use. There is a conversion from grams straight to ounces, and that's wonderful. But I'm trying to teach you the methodology, so we're going to change grams to pounds, and then we're going to change pounds to ounces. So you're going to have to use, you're going to be limited when you change between US and metric to my conversions. And my conversions are awesome. So what I said is that 1 pound is 454 grams. So I think it says that at the top of the page, it says 454 grams equals 1 pound. So when I plug it in, why the 454 is in the denominator on the bottom is because that's how the unit cancels out. Now I didn't do anything, I haven't touched my calculator yet. This unit cancels, not the number, just the unit. Now I look at this piece. This piece, each one of these vertical fractions has to hold true by itself. So there are 16 ounces to 1 pound. One of the things you'll notice as I do it, I always put my units in and then I bring the numbers in. So keep that in mind. It just takes practice. We get a lot of practice over the next week. So by this time next week, you'll all be professionals at it. And I got to my unit. Now you get your calculator out. So there are different ways you can do this on your calculator. There is one correct answer. You can punch across the top, get a number, punch across the bottom, get a number, and then bring them together. You can do the thing where you use parentheses and you do all those parentheses on your calculator. To me, that's a lot of work. So I'm a chemist, and one of the things that chemists and engineers do, and in all honesty, humans in general, is we want to be as efficient as we can be. When I was your age, we didn't have calculators with parentheses, so that's probably why I did it this way. You don't have to punch it in your calculator this way. What I care is that you can do it so that you know what you're doing. And again, that's why I have all these office hours. And so it's having good study habits. So great. All right. Well, I know I also added another office hour. So on Saturday mornings, I actually teach a class. And so I posted it under the Zoom links. Saturday mornings from 10 to 11, I will keep my Zoom link open from the other class when they leave. So if you want to come, some people, they have in the past been popular. Some people are like, yeah, Saturday morning works for me. So my other class actually has an assignment due Saturday night, and I put it there for your class because I know some people have told me they work during the week. So you're welcome to come. Just be patient if you show up, because sometimes I have to wait for the class to finish. All right, how I punch this in my calculator. What I find is some people love this and some people are like, I didn't like it. Find the way that works for you. So 307.65. I ignore the ones, because if you multiply or divide by 1, you have the same number. If my number is in the denominator, I say I'm going to divide now by the 454. If my number is in the numerator, I say, okay, I'm going to multiply. So that's all I do when I put it in my calculator, is I just take this number, I divide, I multiply, and then I hit equal. And I put the squigglies because it's always an approximate. I do not need to see this. And you can put it if that's something that helps you, but you're going to punch it in your calculator. I actually did it before class today, and you'll get an answer. And we're going to talk about significant digits really briefly. Your answer is this whole page. These 4 questions that we're going to do today, they all end up with 3 digits. So you'll have to round your calculator. The next digit was a 2. So you just drop it. You don't need to write the whole number from your calculator. I just need those 3 digits. So for Sig Figs, and again, you'll want to watch the video about Tinkerbell, and we have some homework next week that has Sig Figs, and so we'll refine it and stuff with that. The 2 things that determine Sig Figs are anything that you measure, and those are the ones that are given to you in the problem. So my grams, this has 5 digits. The zeros in between, so it counts. And anytime you go between US to metric. Now, the 4 that I give you on top of this page and everything that I give you, why I like my conversions better than Google is I was consistent with my conversions. If you look at them, they all have 3 Sig Figs. When you go on Google, sometimes they give you 2. They actually like to give you 6 sometimes. They give you a crazy number of Sig Figs. All right, this is exact. When you're within US, when you're within the metric system, they are exact numbers, and that is because these are what are known as a definition. There are 12 inches in a foot. That's how they defined. That wasn't actually the original way. An inch was originally a sun, your finger knuckle. In Chinese medicine, that's how they still measure. And the foot was the emperor's foot, and it changed every time there was a new emperor. But now it became this definition, so you don't change that. All right. That's our first one. I just always pause in case somebody has a question. If you have a question, please ask. Otherwise, I'm going to erase and move on to the next example. And we'll do the practice with the Sig Figs as we go through these. So this is a real story. I wanted to make my questions more interesting than saying 307 grams is how many ounces. So I said, how much does the gnome weigh? This was like 10 years ago. And I got this hit that the Large Hadron Collider, which is where all the physicists work, where they're like finding new particles, subatomic particles, Bose-Higgs particle, and at CERN, they actually asked this question, and they sent this gnome around the globe, and he does actually, to show the globe is not a perfect sphere. And so I then asked myself, how tall is a gnome? And the answer Google gave me was gnomes are knee high. So I measured my knee. So this is how tall my knee is. I'm pretty short. So I got that it's 1.55 feet. And so I said, okay, how many meters is that? Now, some students will say, oh, that's easy. You just divide by 3. There's 3 feet in a meter. That's not true. There's 3 feet in a yard. A meter is actually a little bit longer than a yard. There's actually 3.28 feet a meter. But you're going to have to use my conversions. So we're going to all do this with my conversions just because I can make you have to do that, right? I'm wanting you to learn how to do the conversion factors by doing more than one step. And I don't want you to just keep Googling all your answers. I want you to learn this format because it does help. Even those of you in engineering, I've had students who told me they had an engineering exam and they finished it in 2 minutes because they realized it was like a 3-page problem, and they did it as a factor label and did it in 2 minutes and turned it in and we're the only person in the class that got 100%, and everybody else was doing all this crazy stuff. But if it involves units, you can always do this. All right. Again, you can use parentheses if you prefer that. You're going to see me do these boxes. So I want to go from feet to meters. I'm going to use this conversion. So I want to change my feet to inches, pull the unit down, go to my new unit. So there's 12 inches in a foot. This holds true by itself. And then cross out the feet. I pull the inches down, and I can change to centimeters. So the 2.54 goes on top. The other thing that's really nice about those 4 conversions I give you between US and metric, the US unit always gets the number 1. So it's 1 inch, 1 quart, 1 pound, and then the number goes with the metric. We have one more step, and that is the centimeters. We're going to change to meters. These, the 2.54 centimeters to an inch, that is a bridge between metric and US. And again, there's a multitude of bridges. There are, who knows, not an infinite number, but so many. What I'm doing is limiting your choices, because I have found in my experience, putting clear boundaries makes us more successful. It also allows us working together. If you're working together with another student, that you're able to see where you're going with it. All right, using the chart. If you want with centimeters to meters, and you're really good at metric, and you want to say, well, I know there's 100 centimeters in a meter, and you want to write it like that, I'm okay. That's how I often do it. I'm going to try and be consistent here and use the chart that I posted, because I found that the students who've always struggled with metric, the chart gives them a consistent way to do it. And it's that consistency and the practice that you all end up doing amazing, and everybody has an A+, and we're all happy. All right, so centimeters to meters. The 1 goes with the centi, and on the chart, centi is 10 to the -2, and that cancels. On this one, all the 1s are on the bottom, just happened, which is wonderful. So you just multiply across the top, 3 digits in our answer, 0.472. So on the video, this is again being videotaped. You can always stop me on the video and punch it in and make sure you can get my answer. And if you're not, with the math, it's really easiest for me to be able to verbalize and talk to you. So finding an office hour time that works for you. You can always send me an email and I can try to explain. The other thing I wanted to mention for my Chem 151 class, I am in class on Monday and Wednesday evening from like after 4 o'clock. I don't see my emails until Tuesday morning, and then we start Tuesday morning at 9 o'clock. And so sometimes I don't get to those emails until like late Tuesday or Thursday afternoon. So just realize I will get to it eventually, but sometimes just because of how my schedule is set up, I have to sleep sometime, which I do. And you should all sleep. Sleep is the most important thing. All right, questions? I'm going to erase and do the next one. Practice. This is what our, for those of you in Chem 151, the week 2 folder again opened today, and it has the notes for Tuesday. I made 2 separate sets of notes, one's for Tuesday and one's for Thursday. And the Tuesday notes are, we just do more and more of this. And then Thursday, we move into the periodic table. All right, we're gonna look at a fairy flutters. Now, this is something for you, a warning. Start as far over as you can and find the piece of information you need. All right, so it tells us we have the fairy flutters, fluttering means flying, at 3.14159 meters per second. You want to write it as fractions. We're remodeling my room here to make it so I can teach, and so it's a mess right now. Only 1 unit per box. So I'm going to do something not correctly here. Don't do this, 3.14159, and write it as meters per second over this. You can't do that. It has to be 1 unit, and the per always means the other unit goes on the bottom. I recommend that you always write seconds as SEC, or else you're going to think it's a 5, and you're going to confuse yourself when you go to punch it in. Per means always 1. So per second means per 1 second. All right, where we are going is, I'm going to give myself more space. So on the paper, always start as far over to the left as you can. Don't get mad and frustrated at me and get upset that there's a fairy picture on there. Apparently there's a way you can delete her. I had a student one year who got really upset at my pictures. Don't do that. It's a fairy. Learn how to smile more. All right, the abbreviation for miles is MI. M is meters, so you had to write MI. We also want to write this as a fraction because this is all up and down, vertical, horizontal. And we're going to do this in one flow. That's something I keep forgetting to mention. It says this at the top of the page. Factor label means we only do one flow. We only hit the equal sign on R at one time. So you're not breaking it into multiple steps. I'm going to first change meters to kilometers, and at the top of the page it says 1.61 kilometers equals 1 mile. So I'm going to use this. I'm going to change my meters to kilometers. So I ignore the seconds for now. It's there. I'll come back to it. I write meters, and I'm going to go to kilometers. And then I take this unit. So it's all about the units. My meters would cancel. I pull the unit down, and now I change that to miles. It takes practice. I recommend that today you go back and try this page again on your own. You don't have to print it again. You can just do it on notebook paper and try it without looking. And if you have trouble, you can go back and watch the video. Just watch, stop what I'm doing. My students who were really successful last year, because you'll see as we're going through chemistry, there's a lot of problem solving. When they watch the videos, they would stop me. They would always try the problem first, and then they would watch me solve the problem. When I'm videotaping, I don't give you that luxury. When I used to be in a real class, not in my like little itty bitty bedroom here, I always had that built in. I would do a problem, then I would, for the next problem, give you a chance to try it. So kind of just realize that for those of you who come to lecture, which you all should. All right, that gets me to miles. So meters to kilometer, the 1 goes with the K. So the 1 always goes with the prefix. And then meters, in our handy dandy chart, kilometer means 10 to the third. So that goes there. On most of your calculators, you punch this in as 10 and the caret to the third. If your answers are coming out different with the metric, it has to do with your calculator. This is how I recommend, if you have this key, you can also put it in as 1 and then the exponent key, which would be the E to the third. This E means those 2 keys. I mention this because there are some students who will punch it in as 10E3. And if you do that, you're doing the 10 and you're doing the 10 again, and so you're always off by 10. So just be careful. It's this way or this way. Don't combine them. And then my kilometers will cancel. US gets the 1, 1.61 kilometers. All right, we're not done. We got to miles. We're halfway done. So that's good. Celebrate that. I'll do a happy gnome dance. Now what I have to do is change my seconds to hours, and I'm not going to break this into steps. And I am totally aware there's other ways to do that, but we're learning this for a reason. So this is practicing. This unit is down here in the denominator. We're now going to move it to the numerator. So we pull the seconds to the top. And you could go straight to hours. You'll see me do that sometimes. I'm going to go to minutes. There are 60 seconds in 1 minute. I like to cancel units. I recommend, again, it's a recommendation that you always cancel your units. The students who do that actually do better because they don't get lost. Now I'm here with minutes. So since it's in the denominator, I pull it up and I go to hours. 60 minutes in 1 hour. My minutes cancel. The only units I have left are miles on top and hours on the bottom. So we did it. It takes practice. You can do this thing where you skip from seconds from there to over to here. And you can do that because multiplying and dividing the seconds, it doesn't matter the order that we do the steps in. What matters is that you multiply across the top and you divide on the bottom so that the 60s end up on the top. You would punch this in again, how I would punch it in my calculator. I start here, I ignore all the ones. So I start 3.14159. I divide by 10 to the third. I divide again by 1.61. I multiply by 60, I multiply by 60. So I don't use parentheses at all. 3 Sig Figs again. So our answer is 7.02 miles per hour. When you write your answer, you can use the slash. When you're doing the factor label, you don't use slashes. All right. Got one more. Questions. I sure hope this is videotaping, not how I'm seeing it. I don't want to do this a third time. All right. We're going to do Airy Berry Fitzferry. And I'm going to move down here so I don't have to keep erasing. I'm hoping you can see me down here. If it gets blurry or something, tell me. There's 2 pieces of information with this problem. So we have a 333-pound troll and 1.618 milligrams per kilogram. All right. So this is the dose. What happened to I had a really good pen last night. Let's see if this one works. So this is the dose. Look at that. This is always the dose per body weight. That's a lot to write. Our bodies are large. Our bodies are not as large as a troll, hopefully, but our bodies are talked about in kilograms of body weight. Drugs are always, they're toxins. That's why they work as drugs. We're trying to kill something. This is fluffernutter, by the way. Fluffernutter is a mix of peanut butter and marshmallows, and it probably would kill you in small amounts. But dose is always in small, like milli or micro. If it's like chemotherapy, it's also nanograms and picograms and even femtograms, because just a small amount will be very toxic. All right. One of the things with dosage is you never flip upside down. So just make a note to yourself. You never turn it upside down. It always stays how it is. The other hint that I'm going to tell you, and you're going to see this as we do more practice, when you have 2 pieces of information, I am not in here when we're just learning this, give you extra information. So when you have multiple pieces of information, underline it, like get a colored pen and underline all the information. Find the piece that has 1 unit and start with the 1 unit, meaning it's just pounds. The troll is extra information. So we're going to start there. And what we're solving for, I think, is grams of fluffernutter. Yeah. So this is pounds of the troll. You can draw a troll if you want. And this is grams of fluffer. Okay, this is really weird. This morning, I went on my email, and my top email, their name was actually Fluffer. The email address was Fluffer. I asked them why that was their email, but I thought that was really weird. And this is another weird fact. Fluffernutter, which again is this toxic mix of marshmallows and peanut butter. My birthday is actually National Fluffernutter Day. And everybody's birthday is a national day. And so that's my claim to fame. So that's why fluffernutter shows up in this question. So you can Google when my birthday is. It's coming up really soon. So we will get to that eventually. All right. We use that piece of information. So some students will lightly cross things out as they use them. If you cross stuff out, use something that you can erase in case you make a mistake. We're going to change pounds to kilograms. Now, there is a way you can do it in one step. People who've worked as medics, they know there's 2.2 pounds to a kilogram. I didn't give you that conversion. So again, we're going to use the US to metric conversions that I gave you. I gave you pounds to grams, and then we're going to change our grams to kilograms. Because we're learning this methodology, so when we use the periodic table. So bear with me. Pounds cancels. My conversions are awesome because it's always 1 US to whatever number of metric. The other thing is mine always have 3 Sig Figs. So our answers will pretty much have 3 Sig Figs. The exception is if I started you, if our troll was only 33 pounds, so it was a little troll, then you might be limited to 2 Sig Figs. All right, kilo gets the 1, 10 to the third. You can write it as 1,000 if you prefer. Sometimes I end up doing that. And now the dose comes in. Always the dose is on top over the kilogram. Some students have trouble with the dosage problems because it's a mass over a mass. So a couple of you, like Christian's going to go into pharmacy. You do dosing a lot. There's somebody who's going into nursing or the medical field. You guys do dosing. All right, we're at milligrams. So now we just change our milligrams to grams. Milli gets the 1 using my chart. And milli is not 1,000, it's 1,000th. So 10 to the -3. And my units all canceled, and I'm at grams. And I punch it in, and if you can't see my answer, let me know. You can hear it. It's 0.245 grams. 3 Sig Figs. A reminder, Tinkerbell talks about this. I often leave the 0 off. It's just a habit. You have to show the decimal. If you're going into pharmacy or nursing, always show the 0 because they will mark you wrong. A comment about this page in scientific notation, I would never put any of these numbers into scientific notation because the importance of scientific notation, I think Tinkerbell talked about this, is when you're dealing with really big and really little numbers. None of these numbers are really big or really little. When you start having 4 zeros, you definitely want to use scientific notation. So when it's hard, it goes this chart. Yeah. So sometimes I use the board because it's the way I teach, and I've taught for 25 years. And I've learned that I'm really big expressive, and it actually works, and it works for my students. And it's kind of what Janae was talking about. But I recommend you guys are going to, because everything's take home, right? You're going to want not 10 pages, 20 pages of notes. You're going to want to organize everything into one nice sheet. And that's what this chart is, either like this or how it is, make your own. But how this chart works is you always do 1 in front of the prefix, and then milli is 10 to the -3, so 10 to the power in front of the base unit. So that's where I got that when I did 10 to the -3 grams over 1 milligram in my last step there was from this chart. Again, if you don't like the chart, you've got to be able to show your work and use your conversion and showing it in one flow. I do recognize there's other ways to do these. The students who embrace this and just get it over this next, actually between Mondays when the stuff will be due and we kind of move on, and then next Wednesday we come back to this, it just makes it flow really lovely. All right. Hopefully that answered. Or this page, how dense are you? I'm just, was there a question? Sorry.
Well, sort of. Just wanted to make sure that I was understanding how you did it too. So when you did 1 kilogram over 10 to the 3 grams, is that because you took because it was kg, so you took the K?
Yes. So the K gets the 1 and kilo is 10 to the third. So like if we were doing micro, the 1 would go with the micro and the 10 to negative 6 will go. And so this is why I think that was Tiffany's voice. This is why your lab, you have a bunch of these to practice. And that's what's due on Saturday. It's really not that bad, but just to kind of practice. And then your homework for Monday, 1 page is about the Sig Figs and scientific notation, and then 1 page will kind of look like this, where you're doing practice, and then the worksheet is working through some more of these. So kind of have that on your radar. The worksheets, again, you have until 11:59 at night. So just so you guys know, it's almost 8 o'clock. I'm going to keep going probably for another 20 minutes, but if you have to leave, you can sign out. But I want to go through a couple more things while I'm recording. All right, I actually already recorded this page and I'm going to upload it. It's another Tinkerbell page. And I just want, so density is mass per volume. And so Tinkerbell does a bunch of these problems. So I'm going to actually skip this page and I'm going to move on. So you can just make a note. It will get uploaded. Maybe tonight, maybe tomorrow. You all have other stuff you want to do tonight when you get done. So I'm on page 4 of our notes. And again, I recommend you use these 4 conversions. It actually might be on the midterm that you have to use those conversions. And there are other US to US conversions, like 12 inches to a foot, that you should be familiar with. And I'll make a list of those when we do, maybe when we do our study set, or yeah, maybe on this page. All right, so, oh, and this is the page. So this is going to happen. This is what I thought was going to happen on the previous one. If you see numbers with parentheses, that is the answers. So if you try this at home, like you have to sign out, you're like, yeah, because usually I did that previous page on Monday and then we do this on Wednesday, and a number of students will try this at home. These are there so you know if you get your answer right. So I'm not going to punch these in my calculator. I'm just going to go through the setup, and that's why I can probably do this page in like 16 minutes. Please realize I am videotaping, so I might be going fast, but you can go back and look at the videotape. I actually recommend that you kind of follow along now. You don't have to try and write everything down. I actually recommend maybe you just listen and watch, and then you try this page on your own and you see if you can do it, because that is actually what the purpose of this page is. And how my students in the summer would do stuff like this is they would try the problem, they would have the video up, they would try the problem, and then they would watch me do the problem. Or if they got stuck, then they would watch me. But this is to see, can you do this? I would actually recommend for all of you that you go back and redo this page. So cover up what we did and just do it on another piece of paper and see if you can do it again and do the flow. And using only my conversions up here, and then the common and the metric using the chart. See if you can get the chart down. All right, so let's just go for it. And again, if you have to sign off, many blessings. Have a beautiful weekend. I will be on Thursday night. The link's on there. And if somebody wants me on Saturday morning from 10 to 11, just you shoot me an email or talk to me. And Monday, I will be on at 4:30 because it is math. And I know people want more help on Monday. And so I hope you all have a wonderful weekend as you're signing off. All right, this one, we only have one piece of information and we're solving for meters. So colored pens. This was something, some of my students were really successful last year were, actually Janae was one of them who tipped me into this idea. using color, and you can get these erasable colored pens now. And so underlining the information, so you don't have to see all the words, and then where you're going to. So 11,239 feet. Again, you can use parentheses to do your conversions. I'm going to do it. I really like using these tracks. I'm going to write meters is where I'm going. Of course, you can go feet to meters straight, but that is actually something I'm going to go and fix that on your homework set. You're going to have to use my conversions because I need to see that you guys are working this through, because when we get to the periodic table, there are going to be multiple steps. So I'm going to use this conversion here. I'm going to use centimeters to inches. So pull my unit down, change my feet to inches. Take a deep breath. There's 12 inches in a foot. So Nancy, the US conversions probably are going to be the hardest for you because I know you're from another country, and there's a couple other people, and so we can make a list of the ones. As I said, we'll make a list of the ones you should know. I didn't give myself a space on this page. All right, now I'm going to pull this down. So inch to centimeters. So please notice I always do the unit first, and then I'll put in the number. So US always gets the 1 with my conversions and the 2.54. All right, I recommend crossing units out as you do them, and then centimeters to meters. Now back to the question, and it takes practice. You guys, you knew when you're coming into chemistry, chemistry takes a lot of practice. I don't know if I mentioned, you can actually buy these boards for $8 at Home Depot. It was actually Janae who tipped me into that because she asked me to help her with a question. I'm like, where'd you get that board? And so because she found she did better when she like worked things out really big and then put it on a little piece of paper. So or you can buy smaller dry erase boards, and they're really nice to work stuff out on. You can do 100 centimeters to a meter, but using my chart that's on that page, you put the 1 with centi, and then centi is 10 to negative 2. And then you would punch it in. This limits us to 3 Sig Figs. And so the 0 is a placeholder. Mount Hood is not 343 meters. Sandy is actually at 343 meters because that's about 1,000 feet. So you don't want to lose that 0, but it's not significant. You could change it to scientific notation, and then you would show it as 3.43 times 10 to the 3rd, and the unit goes after. I don't show it in scientific notation because the elevation of mountains is never shown in scientific notation. It's a little weird for my brain. All right, the next one. There's my piece of information, and we're going to go to ounces. All right, so centigrams, ounces. And again, if you don't like the blank, you can draw a flower, you can draw a heart. All right, so the piece you should know here, let's make a list up here. There's 12 feet. Sorry, I can't believe I did that. All right, I can't believe it. 12 inches to 1 foot. These are the conversions for US you should know. There's 3 feet to 1 yard. And there's 5,280 feet in 1 mile. So you make a nice page, put the metric on there, put these four I'll give you. So that's for distance. If it was something like a furlong or a fathom, the depth, a racetrack, I'll give you that. So don't worry about all that stuff. Mass, there are 16 ounces in a pound. So that's 1 pound. And then for volume, there are 2 pints. So PT is a pint to 1 quart. There are 4 quarts in 1 gallon. So like Tiffany, you said you guys went and got ice cream. Hopefully you didn't do a whole gallon of ice cream. Well, you have a lot of people in your house.
We didn't eat the whole gallon, but we did buy the gallon.
I know, and you have a lot of people in your house, and you have a birthday coming up. So that would be actually really good, because that would be 3 weeks into the challenge if you can make it through the birthday without eating all the cake and stuff. There's another one here. This is the one that you'll see me use on a question somewhere. There's 32 fluid ounces in 1 quart. So I want to point this out. This is a mass ounce. This is a fluid ounce. They don't cancel each other out. So these are all volumes. And this is mass. It's not really mass. And then these are distance. So those are some of the US ones, more for those of you who are from other countries and you've never seen these weird units, because they are really weird. That's the conversions. The other ones we run into are money. So 25 cents is a quarter, 5 cents is a nickel, 10 cents is a dime. Hopefully you all know that. And then we just stay in metric after next week, and we just use the periodic table is in the metric system. All right, so I have to get to the base unit. So if you have a prefix, if you're in metric to start with, your step is to get rid of the prefix, the centi. So centi means 10 to the negative 2. Now we're at grams. I look up here, and here we go. There's my conversion, grams to pounds. So I pull the grams down, and I can get to the US unit. And the US gets a 1.454. All right, cancel my grams. And then again, you guys can have your nice handy dandy sheet. And a pound is 16 ounces. And you would punch it in, and you get that number. I talked about this with Tinkerbell. That number does not have to be in scientific notation. It doesn't have that many zeros. When you get to start having 3, 4, 5, well, definitely 4 zeros, you have to be in scientific notation. So I can look at that number and count the zeros. I'm going to write it in scientific notation for practice, because I know some of you would like that practice. So scientific notation, again, is 1 non-zero digit to the left of the decimal. So 1.52 times 10, and this would be to the negative 3. It is a number less than 1, so it's a negative exponent, and I had to move my decimal 3 places. It's not the number of zeros, it's how many places you move the decimal. And then the unit goes after the scientific notation. I also wanted to mention, you can write it as 1.52, capital E, negative 3 ounces. You're not going to see me do that. Sometimes I do, actually, when I'm writing something and don't have space. Little e means something different, but some of you are at higher math levels and you like the capital E. That's great. I know what that means. All right, moving on. The mushroom, this is like phenomenal graph knowledge. We should all be driving mushrooms. And we're going to miles per gallon. So we're going to be doing 2 units. And again, you can draw a flower or whatever you like in your empty space. So we want to put them one on top of the other. And again, for those of you staying, I know I'm going fast, print this page again, do this page. You can listen to the video, but try every one, or listen to the video, but don't just copy, and then try it and see if you can do it. So you guys actually have a huge advantage in this format. I'm like seeing, I'm not saying I like this. I would really like to meet all of you. I'm in the store today and I'm like, I wonder if any of these people are my students. I actually had that happen in the spring. I was in the store and this woman started following me around and I was kind of like, what? And this before we had to wear masks, right? And I'm like, why is she? And then also I looked at her and I said, you're in my class. And she said, you're my chemistry teacher. And so I recognized her from the Zoom thing. All right, 1 unit in each box, 1 on each layer. At the end, write it as one on top of the other. So we're going to change kilometers to miles, and we're going to change liters to gallons. We're going to do it in one flow. When you write your answer, you can do a slash, but in this factor label, only 1 unit on each level. Right, so I'm going to start with kilometers, and I pull it down. By the way, the per means 1. So the denominator gets the 1 whenever you see the per. So I'm going to change kilometers. Oh, look at that. Kilometers to miles. I give it to you. Again, right, miles is MI. Miles gets the number 1 because it's US. And the 1.61 goes with the kilometers. Cross out units. We don't cross out the miles. We want the miles. Just something I do that helps me in teaching. I got a unit. I'm halfway done. Woohoo! Right. Liters. I pull it up. If you're at the bottom, you go up now, and I give you, I give you that bridge. So I'm going to go to quarts. So US, my conversions. Again, I'm going to make it that you have to use my conversions because I know where we go with this next week, and it will make it easier also because a couple of you have made study groups. It will make it easier because that way you're all going the same path. All right. So I'm not, the answer is only part of it. The path, actually, it's like anything. It's the journey that is the important, just as important. Crossing out our units. We're at quarts. We want to go to gallons. That's a Q, by the way. I make my Qs funny. People have told me. There are 4 quarts in a gallon. And yeah, so you're probably figuring you want notebook paper, and if you can print the notes, that helps. I didn't give as much space as I should have on the notes, I'm realizing. All right, and we're done. We have miles per gallon, 3 Sig Figs, because again, my conversions have 3, the number we started with, so you get 666. All right, number 4. We have 2 pieces of information. And the question wants us to find minutes. And on these and on the homework, maybe even on the worksheet, yeah, on the worksheet, I also give handy dandy hints. On the midterm, probably I won't, but this handy dandy hint, you'll hear me keep saying, it eventually disappears. If you have 2 pieces of information, what students do, students want to start with the first piece of information. Don't do that. I'm looking to see if I have a pencil. I'm going to show you why that won't work. So don't do this. Don't copy this down. If you started here as centimeters over 1 second, so per means 1 second, your seconds are in the denominator. How are you going to get to minutes if the seconds are on the bottom? So don't start there. That's just wrong. Anytime I give you 2 pieces of information, start with the one that has 1 unit and draw your heart or flower or unicorn or football or whatever, pie, cake. You can draw your cake and eat it too. Here we go. Draw a birthday cake, candles. And right, you can draw as elaborate a picture as you want. I am going to use this, and the piece of information I want from that right now is I need to get to centimeters, because this piece of information is going to allow me to change from centimeters to seconds, from distance to time. It only holds true for this question that has to do with butterflies fluttering. All right. So I have to get from miles to centimeters. We can do this. I tell you how to go from miles to kilometers. I'm going to do that way. You could also go miles to feet, feet to inches, inches to centimeters. But I'm going to go metric because there were questions about the metric thing I was doing. So I'm going to go 1 mile to kilometers. So 1 mile is 1.61 kilometer. Again, the units tell you what direction, what goes on top, what goes on the bottom. So in the previous one, the 1.61 was in the denominator because that's how our units worked out. It's all in the units. It's magical. It's awesome once you get the flow of this. All right. In metric, you get rid of the prefix, go to the base unit, kilometers to meters, and then we'll put on a new unit. So I get rid of the K, go to meters, and now I can put on the centimeters. You don't do it in one step. You're going to have to do it in 2 steps. And you just accept that. It works much better. Kilo and centi get the 1. The prefix gets the number 1. And then you'll look at your little thing and you say, okay, kilos 10 to 3, centis 10 to -2. So they go with the base units. I think this was the question some people were asking earlier. You have to practice. You have to keep doing this, and then you'll get it. It's like the stuff we did with the periodic table. And yeah, we've learned a lot in this first week. It's nice having all of last week off. All right, I'm going to cancel units. I'm at centimeters. I need to get to minutes. So a quick comment for you. Some of these, and the worksheet does this too, they build and they get longer. Give yourself the space that you can start way over here, like I did not do. So, and then don't get upset about my pictures. I had a student one year who got upset about my butterfly, and she said it got in her way. It's a butterfly. Butterflies never get in the way. We need this bridge. Highlighters also help. So 536 centimeters to 1 second. So this is going to trip some of you out, but if it has 2 units, you can flip it upside down. The number stays with the top unit. The per seconds is 1 second. You flip it because that's how the units cancel out. In that page 3, the density page that Tinkerbell is going to show you how to do, she does that. She flips things upside down because she has the magic of the fairies. You got the seconds and 60 seconds to 1 minute. And you'll get up there. And again, I know I'm going fast, but you guys are going to have to go back and work on this. And that is the setup. That's what you're going for. All right. Circle our information. And again, you can go back and watch the video. Just keep moving on with me. My question, which piece of information do we start with?
The one that only has 1 set of units.
Yes, thank you. You are all thinking that. And start as far over as you can so you don't run into the lemonade. It's lemonade. Don't get angry at it. Think, ooh, lemonade without sugar. You can make amazing lemonade without artificial stuff too. All right, draw whatever you want, your heart or whatever. So this is quartz. I need to use this. I'm not going to give you extra information. This is density. And the piece I need is I need to get the quartz to the milliliters, and then I'll use this piece of information. So up at the top, I go quartz to liters. So let's get out of this US stuff. So quart to a liter, 1.946. And then I'm going to go to milliliters. So liters to milliliters, Milli gets the 1. If you're using my chart, milli gets the 1. We're defining the prefix always gets the 1, and the 10 to negative 3 goes with the liters. Now, there is partial credit. If you show your work, and your work is shown beautifully, and you flipped one piece, so your answer's wrong, you're going to get part credit. But if you show your work, it makes it easy for me to see where you got wrong. Now this comes in here, and this is something, this is only true if you're working with this refreshing tart lemonade. This density is different for every substance that you work with. And so you either will be solving for density or you'll be given it. Same with here, the rate. This was only true for the butterfly. So you have to go with the number in the question. These conversions, the metric table, these conversions, those are ones that you can use for any of the problems that you need it. So make your own conversions just using those. Don't go crazy with, there's huge conversion charts online that will have 100 conversions and you'll get lost. I get lost. All right, so I'm at grams. Oh, I forgot to write down where I'm going, which is pounds. And again, I'm not going to give you extra information. So I gave you grams and pounds. So I can do that conversion. If you do all the work that I give you, if you go back and redo your notes, if you use my conversions, you will become so proficient and fast at this because you'll just know, oh, I want grams and pounds. I know that. And you won't even have to look at your little note card. And you would punch it in, 3 Sig Figs, seems to be our motto tonight. All right, last one. Again, 2 pieces of information. You start with the one that has 1 unit. So 1.618 pounds. I am trying to get to pints. And I don't like, we get rid of pounds. I usually don't use them. I'm amazed it showed up so much on this page. And the reason I don't like to use them is the L makes it look like a 1 and everybody punches the 1 in. All right, I'm going to go to grams, right? That's how we get to metric, is pounds to grams. Chemists work with small masses, and so that's why I use that conversion actually. It's because chemists are developing new chemicals. They're often toxic or smell, and so they work with very small amounts. All right, so we're at grams. I can now use this conversion. That's the density of gold. It is only going to be true for this problem if we work with gold. Different websites give different densities, so just go with the number I give you. Now, this is the interesting piece. It's the units. And if you get this question, then you've got this. You've got all this pieces. 3 Sig Figs. Tinkerbell did her job. We have to flip the density upside down on its head. So my question is why? Make this a bonus point. If anybody can tell me why I flipped the density on its head.
Is that the only way to get rid of the grams?
It is all about the units. Is that Tiffany? It sounds like Tiffany.
Yeah.
Make a note. Tiffany and Nancy get the bonus points tonight. Oh, I actually remember that. Yeah, see, it's worth staying late. Yeah, it's all about the units. We forgot our heart here. All right, it's all about the units. Density is always mass per volume. If I ask you what is the density, it is always the mass on top. But in unit conversions, things flip, so the units cancel. Also, when density flips, the number stays with the mass. So the 19.3 stays with the mass. Like up here, the 536 stayed with the centimeters. All right, we're at milliliters. We have to get to pints. You're limited to my paths because I have that power, it turns out. So we're going to do liters to quarts. Oh, geez. So you got this. milliliters to liters. Milli gets the 1. 10 to negative 3 goes to liters. If you go back and do these practice, you've got this. The homework has a page of these, I think 5 or 6, and then your worksheet actually has 6 because there's a bonus one. So you do 5, you get the 5. If you do the 6th one, you can get a bonus point. Look at all these bonus points your teacher wants. I don't want to be at the final either. So all of you do the bonus, and then maybe we can go have a celebration for the final. Let's do a Zoom celebration, right? We can all go out to a restaurant, actually. We can all go to a restaurant or a bar, but we can't go to campus. All right. You can see I have a little pet peeve about this. All right, liters to quarts. Oh, wow. So US gets the 1.946. I'm just excited. I'm almost done. And then the unit quarts to pints. And take a deep breath. If you don't know it, you have your little hand. Sorry, keep moving back and forth. You have your little thing here. 2 pints to a quart. So a lot of you look like you were small people like gnomes, called pint size because pints are small. So 2 pints fit into a quart. And 3 Sig Figs again. So even though our original number had 4, this had 3. My US to metric conversions had 3. This was exact. US to US, those are exact. So 3. The leading zeros are not significant. You don't have to show this in scientific notation. If you wanted to, it would be 8.04 times 10 to the negative 2 pints. And now I am going to offer a bonus point if you email me, so none of you can say the answer. This is a tough bonus point, but this is how my mind thinks. This number, not with the pounds, but that number 1.618, it shows up a lot because it's a really special number in the universe. So if you can email me and tell me, you have to explain what is important, why that number is so special. It's 1.618. And so you'll have to write me a little thing about it to get the point. All the points are awesome. And those of you who are here, you can send me an email too. You can all send me an email. There's a limit until the next class. Like Monday, I cut off my extra credit point and we move on. All right. Is there questions, those of you who are here? I'm going to stop recording. If